Swayam Prabha. Digital India. Educated India.
Hello and welcome everyone. We are learning about the basics of building construction, and today we are going to talk about masonry and its types. I hope you've already taken a look at the lecture just before this, which was talking about brick masonry. In this particular lecture, we are going to concentrate on stone and composite masonry, and we are going to talk about arches and their types. So this is the second part of module 2. Let's start with stone masonry today. In stone masonry, walls and other parts of the building are made using stones, which may either be natural in shape or they may be shaped into desired forms using certain tools. Now, stones are arranged together with mortar, which acts as a binding agent to create walls or other elements. So we can even create piers or columns using stone masonry, in which case we are either using stone faces which are rough, or we have dressed it to make it more regular in shape. So depending upon the type of the surface finishes, we can categorize our stone masonry into some types. The first is called the rock faced or quarry faced finish. In this, the exposed face of the stone retains the natural texture of the stone. So it will look rough, and light hammering may be used to remove projections which are beyond 80 mm from the desired vertical face. So despite the fact that the stone has some jagged edges, it is rough in shape, we want to give it at least a horizontal look. From the vertical face, we have to ensure that more than 80 mm of projection is removed. So for that, a little bit of light hammering might be required. We can see what the rock faced finish can look like in this figure. The scabbing finish is one in which the stone is dressed roughly, and scabbing hammer is used to remove any irregular projection. So in this example, we can see the figure given below. The scabbing finish is slightly more regular looking from the previous example where we have the rock finish, because a bit more dressing has been done on the stone. The hammer dressed finish is one in which the hammer is used to give the stones roughly a square or rectangular shape. So we are almost trying to cut the stones to the shapes of bricks. It might not be the exact standard sizes like we get in case of the brick, where we have very regular and sharp edges. Here that won't be possible, but we can more or less arrive at a squarish or rectangular shape. Definitely that kind of a stone has to be used, which can be hammered to the finish. And the joints are such that they are about 75 to 100 mm back from the face to give appearance of grooves. We can also have something called the axed finish. This is often used for hard stones like granites, where an axe is used for the dressing of the stone. So the punched, broached or stugged finish is a rough form of a dressing. It is usually used in the lower parts of the building. Depressions or punch holes are made on the exposed surface of the stone using a punch. So it becomes very clear that if we are going for stone masonry, we will have to dress the stone before we can use it for our construction. This is where brick masonry becomes more preferable in most regions, except for when they are not easily available, or stones are more easily available or are cheaper and can be used in construction. That's because bricks can be used without dressing. It can be used as it arrives on site. Whereas in case of stone, a lot of finishing has to be done before we can go ahead with the laying of masonry courses. The picked finish is similar to the punched finish, but instead of a punch, a pointed tool is used to create small pits on the exposed face. The boasted or droved finish has a series of 38 to 50 mm wide parallel bands, as one can see in this figure, and it is created either horizontally, vertically. So it's almost like the the stone masonry units have been splayed with parallel bands. The vermiculated finish are stones which have irregular grooves on them. It kind of looks like worm tracks. The reticulated finish is similar to the vermiculated finish, but the veins are less winding and they're linked to form polygons or irregular shaped reticules. So one can see how the vermiculated finish and the reticulated finish look like. So that was the classification of stone masonry depending upon the finish of the external face of the wall. We can further classify stone masonry depending on the arrangement, depending on the way we arrange the stones in the construction, and of course the overall look that is achieved through that arrangement. Rubble masonry, in this case, the blocks of stone are used in either undressed or comparatively roughly dressed condition. So it will have a very rough look where in a zigzag pattern the stones of different shapes and sizes come together to form the finish. In ashlar masonry, the blocks are more accurately dressed, so we will give it a particular shape, there will be more regularity, and there will be a pattern in which we can arrange them. So they are extremely fine bed and end joints, and the height of the stone varies from between 25 to 30 centimeters, slightly more than what we were dealing with in brick masonry. When we are dealing with stone masonry, we also have to understand that different types of joints will have to be created. This is to ensure that some amount of lapping happens in adjacent stone units, also to increase the strength of the wall and to ensure proper bonding in our structure. The butt joint or the square joint is the most commonly used joint, and it is the simplest one. Here the dressed faces of two stones are placed adjacent to each other. So there is no overlap, no consecutive pattern. It's just a simple placing stones next to each other. The rebated or lap joint is usually provided in stone arches, gables, copings to add stability and to prevent movement in the stones. So to be able to do that, we create a lap at least 70 mm. We do not want any lap which is less than that, and we can place the lap in a rebated form. It can either be straight or it can be at an angle. The tongue and groove joint or the joggle joint is used to prevent slipping along the side joints, and there is a projection or a tongue which is provided on one stone, and there is a groove alternatively provided in the adjacent stone. So the tongue fits into the groove, and that allows us to bond the stones in such a way that slipping does not happen at the joints. The table or bed joint is similar to the tongue and groove joint. The only difference is it is happening between successive courses instead of on adjacent stones. So here we are preventing lateral movement of the stones. The joggle is created on one face, and the projection height is kept to about 30 to 40 mm, and the width is 1/3 of the breadth of the stone. So in each consecutive layer we are creating this bed joint. The cramp joint is one in which a non-corrosive metal clamp is used. So we use grout to seal this with cement, lead or asphalt, and this sort of a cramp, different other shapes of cramps are also possible to be used, and we use that to hold the two adjacent stones together. The plug joint is similar to the cramp joint, but here the plug holes of dovetail shape are used instead of the non-corrosive metal clamps. So we are using some sort of a dovetail shaped plug to hold the adjacent stones together. So these are the different types of joints we are studying. So the dowel joint is another type in which the rectangular holes are made in each stone, and dowels of hard stone, slate, gunmetal, brass, bronze or copper are inserted and sealed with cement mortar. So this is the dowel, very similar to what we were doing with the clamps. We are using a dowel in this case, which could be made of any other type of stone or of metal, and we are sealing it in with cement mortar to hold the adjacent stones together. The rusticated joint is used in stones whose edges are below the general level, such as for plinths, etc. So this is what the rusticated joint can look like. The saddled or water joint is used in cornices or other weathered surfaces which are in direct contact with water. So we want to divert the water away from the joint, and the saddle is beveled backwards from the front face. So this is very similar to what we do in case of drip courses, let's say in ease boards or chhajjas above our window openings, let's say. So where we are trying to drive the water away from the opening. So similarly in this case, to keep the water away from the joint, we want a slight curve or the saddle joint into the stone to drive the water, divert the water away from the joint. So those were the different types of joints, and before that we took a look at different types of finishes that we can have in our stone masonry. Let's now get started with composite masonry. Composite masonry is constructed out of two or more different types of building units or different types of materials. So in this, what we are doing is we are either trying to improve the appearance of the wall, or we are trying to make an efficient utilization of locally available materials to optimize their economy or the cost of construction. So in this case, whatever material is available to us on site, we can do a combination of both to save on our expenditure, or we can want to use a certain type of material for strength but give another type of aesthetic appearance to a facade. For that we might go for a combination of two materials. So it could either be a combination of stone composite masonry, that is we are going for two different types of stone finishes or arrangement in stone masonry, or we can give a combination of brick and stone to make a composite masonry. So if we are going for a stone composite masonry, here it is generally a combination of ashlar and rubble masonry. So we know we've already learnt that ashlar and rubble masonry have very different look to each other, because one, which is the ashlar, has far more well dressed stones. So if we make a combination of both, we can actually have the regularity of courses in the ashlar part, whereas have the rough look of the rubble masonry as well. It could also be because we are trying to use well dressed stones for only a part of the construction and do away with the expenditure of using well dressed stone throughout the construction. So we might want to have rough rubble masonry at certain part and just dress up the front facade. Now rubble masonry is generally used in the backing of the wall to reduce the cost, and for the front facade, for a pleasing appearance, we go for the ashlar masonry. The important factors that we should consider is that through stones, this is very important, through stones should be used at regular intervals and in sufficient manner. So what do we mean by through stones? Now in case of random rubble masonry, where we have different bricks randomly being brought together, to ensure that proper bond is maintained, we need to have some well dressed through stones which cover, if not the entire width of the wall, at least 3/4 width. So at least 3/4 width. Now this acts as a good overlap mechanism which helps us bind the entire wall in rubble masonry. So this is called a through stone, and it is important for us to use this at regular intervals, especially if we are using stone masonry in places which are earthquake prone or seismic prone. It is very, very imperative to use through stones properly dressed, which at least cover the entire width of the wall, not just 3/4, because if it's in a seismic prone zone, there's a fair chance that in case of an earthquake, the two leaves of the wall will just crumble throughout the central portion. So it will just fall apart if we do not have through stones holding it together. So it's a very important characteristic when we are dealing with composite masonry, especially because we are trying to connect two different types of stone masonry together in one single wall. So for it to act in a consolidated manner, to act together, the two leaves of the wall or two whites of the wall have to be connected using through stones. The backing and facing portions should be constructed in rich cement mortar. Mortar is very important to ensure strength of the wall. The construction of both the backing and the facing should be carried out simultaneously so that proper bond is maintained. So you do not want to create the random rubble part first and then add the ashlar as a cosmetic treatment on top. You want to do both together so that they act together and become consolidated and act as the same wall, not two halves or two leaves. If necessary, metal clamps, dowels, plugs, etc. have to be introduced to ensure that the backing and the facing act together or are well bonded together. Just like stone composite masonry, we can also go for a combination of brick and stone composite masonry. The brick stone composite masonry may essentially be of three types. The first is brick backed ashlar masonry. So as the name suggests, as we can see in this particular figure, the facing of the front wall is made up of ashlar and the backing is completely made up of bricks. Now where would this find application? Let's say we want to go for the aesthetic appearance of a stone building. So we want our front facade to look like it is made up of stone, and we want a regular ashlar masonry for that. For the inside facade, if you are using bricks, it becomes easier for us to add interior finishes to the wall. It's easy to hammer or nail things or fittings and fixtures onto the wall, which is difficult to do in case of stone masonry. Fitting something, let's say a piece of plywood or furniture or a rack would be difficult to do in case of stone. So we want the internal fascia of the wall to be made up of bricks. Just like the brick backed ashlar masonry, it is also possible for us to go for the brick backed stone slab masonry. So the internal wall is made up of, the face of the wall is made up of, let's say, brick, and only the front facade has got stone slabs or tiles. So this is very similar to what we know as cladding. But in case of cladding, stones are fixed on with the help of dowels. Similar to this, stone slabs or tiles can also be used in a consolidated manner while making the wall itself. So it becomes composite masonry. The last type, or the third type of brick stone composite masonry, is called rubble backed brick masonry. So instead of the first example in which we had brick backing and ashlar facing, here we are creating brick facing and rubble backing. So the internal backing of the wall is made up of rubble, that is for the economic saving portion, and because maybe bricks are not very commonly available here, we want to make the majority of the wall with the help of rubble backing. And the front facade, we want to give a brick look, maybe an exposed brickwork, and that is the aesthetic we are going for. In that case, it's a rubble backed brick masonry, composite masonry example. So there are three ways in which we can make a combination of stone and brick in our composite masonry. Another example of masonry is the cement concrete masonry. Let's take a look at this. So in this case, we are using either hollow or solid cement concrete blocks. We can use it for wall construction with or without stone facing. So if we are okay with having the external facade of concrete blocks, we can go ahead and use that, or we can always add some other element for the external facade, for example, stone facing. The recommended size of the blocks are 39 cm cross 19 cm cross 30 cm, or 39 cross 19 cross 20, or 39 cross 19 cross 10. So it has to be a regular standard size which is certified, and we want to use mostly the same pattern or size of unit for constructing a particular wall. That way we can stick to the pattern in our courses. The aggregates used in these blocks consist of 60% fine aggregates and 40% coarse aggregates. The strength required for these blocks should be at least 3 Newton per millimeter square. So after the concrete blocks are made, we want to go for testing their strength as well before using them in construction. Normally, certified standard concrete blocks are of sufficient strength. It may be of two types. We can use regular concrete blocks. These are manufactured from dense aggregate, and they are generally used for load bearing walls because these concrete blocks are solid. They do not have any opening within itself. So they are able to take greater load, but definitely they will be heavier. The hollow concrete blocks have a void inside their core, and this void is greater than 25% of the gross area. Generally, they are also made of lightweight aggregates, and they can be used for both load bearing as well as non-load bearing walls. So if you want to go for partition walls or filler walls and we want it to be lighter in weight, we can opt for the hollow concrete blocks instead of regular concrete blocks. Also, the air gap within the hollow concrete blocks might have additional thermal insulation properties. So, these are some examples of how we can use different types of cement concrete blocks. This is an example of a stretcher block. These are used in the corners and are called the corner blocks. We have double corner blocks. In the corner block, we had an opening here, but the double corner block, we have solid faces on both sides. The jam blocks will have certain rivets on the sides. Partition blocks are much lesser in thickness, as you can see, almost half the width. Solid blocks have their own applications. At the lintel or beam level, we have another look. These are floor blocks. A frog block is such created that it can create a key for mortar. This is a bullnose block which has a bit of a curve, splayed edge or corner, and the lintel block. So, different types of voids can be created in our blocks, and they find application in different parts of our building construction. So, the component that we are dealing with, that is it a jam or is it a lintel portion? Do we need a solid block here or a hollow block here? Is it required to have a rebate or not? So, based on the specific component of construction we are dealing with or the part of the wall we are dealing with, we can opt for the specific type of block. Hollow clay block masonry is another example in which we can use hollow clay blocks or tiles which are made up of selected clay or diatomaceous earth, and then it is dried and burnt and applied in our masonry construction. It's used for building foundations, walls, partitions, floors and other structural members as well. Now, even though walls are relatively thin in comparison to the conventional brick walls, the walls are quite strong and they are light in weight as well. We might be able to save on the floor space area if we are going for a thinner tile or hollow clay block. It might reduce the thickness of the wall and increase the carpet area of our spaces. It can also provide better thermal insulation due to the presence of large amount of air within the cells of these blocks. So, many a times because as the name suggests, it's a hollow clay block, so there are gaps within these blocks which can provide thermal insulation properties. So, some examples of different types of partition blocks or fixing blocks which may be used. We might go for a much more solid, robust example for load bearing blocks. There might be ones which are rug faced. Different units are designed for the floor units, the conduit blocks, and other special units may also be created for different applications within the components of construction. Reinforced brick masonry is a modification of brick masonry where we have introduced some amount of reinforcement. Now, reinforced block is such that we are strengthening with the provision of mild steel flats, hoop iron, expanded mesh or bars. So, we can either go for bars, meshes, flats. These metal members are being introduced into our brick masonry to strengthen the wall further and increase its ability to take loads. This can be adopted in many circumstances. First of all, let's say if we require the wall to bear tensile and shear strength, we might use reinforcement. When it is required to increase the longitudinal bond, when the brickwork is supported on soil which is susceptible to large settlement. If the brickwork is supposed to act as a beam or lintel over openings, especially if it's large openings, or even if you are dealing with openings in earthquake prone area. When the brickwork is required to resist lateral loads, for example, it is being applied in retaining walls. So, some amount of lateral load will be coming in from the sides. So, we might want to go for reinforcement there. When the brick wall is to carry heavy compressive loads, a lot of superimposed loads, and as I mentioned, if it is in seismic prone areas, then we might go for reinforcement. In seismic prone areas, it is best to go for both vertical as well as horizontal bands of reinforcement in our brick masonry, because most of the masonry will fail in the portions next to the openings. So, if we have a wall with openings, these portions are particularly susceptible to crack formation, X-crack formation to be exact, during, let's say, seismic activity. So we might want to go for horizontal as well as vertical reinforcements to ensure that we can hold the entire wall together. So this is just one of the applications of reinforced brick masonry. Of course, in normal context, if we have greater load, if the soil is susceptible to settlement, if lateral loads are coming in, we can opt for reinforcement in our brick masonry and make a combination of both. Reinforced brick masonry can be laid either horizontally or vertical, as I mentioned already. In case of horizontal reinforcement for walls, it consists of either wrought iron, flat bars, hoop iron or steel mesh. For vertical reinforcement for brick columns, walls and retaining walls, we can go for mild steel bars. So let's take a look at these figures. We can see how iron hoop has been used in the reinforcement. We can also use meshes in our walls in layers. Different bars may be introduced. Main bars and other ties to ensure that reinforcement is introduced into the brick masonry. So this is reinforced brick masonry. Here we can see how vertical reinforcement is provided. So in different courses we can alternate the arrangement in the bricks, and the reinforcement continues through the same positions. Just the arrangement of the brick alternates in each course. So the next type of masonry we're dealing with is glass block masonry. Here, of course, it's just like brick masonry. The only difference is the blocks are made up of glass. Now this is used in construction of walls, floors and partitions. It's very common in commercial properties, for example restaurants, or we may even use it in outdoor constructions as demonstrated in the picture here. So what we are doing is we are maintaining some amount of visual opacity, but we are allowing light transmission, and of course the aesthetic appeal of the wall structure is improved and we have a much more open light appearance to our area. So if you want a structure or a place where a lot of light comes in, but we also want some amount of opacity and visual separation or segregation of spaces, we can go for this option. Here we use spacers and panels for reinforcement to ensure that the glass blocks are placed at regular intervals and fixed in their position with the help of mortar. A lot of skilled finishing will be required in this case to ensure that the wall has an appealing look in the end. So these were the different type of masonry. We had in the last lecture talked about brick masonry in detail. In this lecture, we addressed stone masonry, concrete block, composite, and of course we ended up with hollow block, reinforced brick masonry, and finally glass block. So we have taken a look at different types of masonry that we can use and how they can be arranged to create walls, where they find application, and what type of finish they can offer. Now after this we are going to venture into understanding how arches are created in our construction. Now what are arches? There are structures which are constructed of wedge-shaped units. They may be bricks or stones, which are jointed together with mortar and spanning an opening to support the weight of the wall above it along with other superimposed loads. So instead of going for a conventional straight opening where we have a lintel on top, we can also opt for arches to span large gaps. And arches have the ability to not only support themselves and also take the superimposed load of the wall as well as the loads from above that appear to come above this arch. Now in an arch, we have to first understand various terms which are used to describe different components of an arch. Before we get started, we will first take a look at the elements of an arch. So the first thing we need to know is the intradose. Intradose is the inner curve of an arch. So this face, this is going to be the intradose. This is also often called the soffit or the inner surface of an arch. So we can either call it the soffit or the intradose. The extradose is just the outer curve of this arch. So this portion is known as the extradose. The voisers are the wedge-shaped units of masonry which are forming this particular arch. So each of these wedge-shaped units which are placed next to each other, these are the voisers. The crown is the highest point of the extradose. So the extradose was the outer curve. So this highest point right here is known as the crown. Key is the wedge-shaped unit fixed at the crown of the arch. So this particular unit right in the center, jutting out, this is known as the key. This is, in fact, as the name suggests, is the key to holding the arch in its position. The spandrel is a curved triangular space which is formed between the extradose and the horizontal line through the crown. So if I draw a line through the crown, that is the highest point of the extradose, there will be a triangular space which is created. This is known as the spandrel. The skewback is the inclined or splayed surface on the abutment which is prepared to receive the arch and from which the arch springs. So this is the skewback right here at the corner. This is where the arch will spring from. The springing points are points from which the curve of the arch springs. So at the edge we are going to have some points from which the arch springs. These are the springing points, and if one connects these springing points with an imaginary line like so, this is the springing line. The springer is the first voiser at the springing level and it is immediately adjacent to the skewback. So that means the first voiser that I place at the skewback is going to be called a springer, and we gradually move our way towards the crown, and the last voiser which is at the tip of my crown is known as the key, which we had already taken a look at. The abutment is the end support of an arch. So the abutment is right here at the edge. This is what is supporting the arch. The arcade is a row of arches in continuation. The haunch is the lower half of the arch between the crown and the skewback. So between the crown, which is here, and the skewback, which is here, this lower half is known as the haunch. The ring is the circular course which is forming an arch. An arch may be made up of one or more of such rings. The impost is the projecting course at the upper part of the pier or abutment to stress the springing line. So right at the top part of the abutment or pier, which is at the sides of the arch, that projecting course is known as the impost. The bed joints are joints between the voisers which radiate from the center. So between each adjacent voiser we have these joints. These are the bed joints. The center or striking point is the geometrical central point from where the arcs forming the extradose, arch springs and the intradose are described or struck. So the striking point is going to be right at the center from where, right here, the center. So the extradose, the intradose, the arch rings, we may have multiple rings also, each of which is radiating, or we can strike it from a certain point, that is the striking point or the center. So if we are drawing this arch with the help of a compass, somewhere that the central point of a compass rests is the striking point. The span is the clear horizontal distance between the supports. So if I have an arch along the springing line, This clear distance is the span. And the vertical distance between the highest point of the intradose, we are dealing with the intradose, not the extradose, we are just dealing with the intradose. The highest point, from there if we take a vertical distance to the springing line, this is known as the rise. The perpendicular distance between the intradose and the extradose is known as the depth or height of the arch. So, this distance between the intradose and the extradose, this is known as the depth or height of the arch. The thickness or breadth of soffit is the horizontal distance measured perpendicular to the front and back of the arch. So, that means when I am looking at the arch, the distance between the intradose and the extradose is my depth or height, but there is also a three-dimensional aspect within, into the arch, which we cannot see in two dimension, right? So, that is the thickness or the breadth or soffit. So, those were the different parts of an arch. It's important for us to remember the terminology, especially when we are learning further about arches, because failing which we will not be able to understand exactly how each of the arches are designed or made without knowing the technical terms associated with it. Now, how does an arch remain stable? What does an arch in fact do? An arch transmits the superimposed load to the side walls or abutments through friction between the surface of the voisers and the cohesion of mortar. So, we have different voisers placed next to each other, they have bed joints in between. So, this friction is helping us keep this entire arch together, and with this it is able to take even the superimposed loads placed on top of it. Now, every element of arch remains in compression, and an arch may fail due to the following reasons. One is there is crushing of masonry. Two is there sliding of a voiser. So, each of these voisers are strategically placed and held together with the key in the center, which is at the crown of the extradose. That voiser is holding everything together, which is why it's called the key. If any of the voisers slips, this arch is going to fail. The stability of the arch will be hampered. Rotation of some joint about an edge can happen, or there might be an uneven settlement of the abutment of pier. So, if one of the abutments on the sides or both settle down, it might lead to lack of stability in my arch. Now, let's start classifying arches. We can classify arches based on several characteristics. For example, on the basis of shape, we can have many types of arches. For example, flat arch, segmental arch, semicircular arch, horseshoe arch, pointed arch or also called the Gothic arch, the Venetian arch, Florentine arch, relieving arch, stilled arch and semi-elliptical arch. So, many names are associated with different shapes of arches. We can classify arches on the number of centers as well. We know what is the center, that is from where the extradose, intradose and the arch rings are stricken. So, based on that number of centers which are available in an arch, we can classify them as one centered arch, two centered arch, three centered arch or four centered arch. So, multiple centers are also possible in our arch shape. We will see how that is possible. We can classify arches further on the basis of materials and workmanship. So, stone arches can be rubble or ashlar. Brick arches may be rough arches, axed or rough cut arch, gorged arch, purpose made brick arch, etc. And concrete arches can be made with concrete block units or monolithic. So, based on the type of materials that we use and the type of workmanship we apply, we can further classify our arches. Let's now dive into the details of each classification. First, let's talk about the classification of arches based on shapes. The first type is called a flat arch. Usually has the angle formed by skew backs at 60 degrees with the horizontal. So, we know what is the skew back? That is this line. This is forming a 60-degree angle with the horizontal, thus forming an equilateral triangle with the intradose at the base. The segmental arch is a common type of arch used for buildings whose center of arch lies below the springing line. This is the springing line. The segmental arch's center has to lie somewhere below it. What does this mean? It means that this is only part of an arc. It is not a semicircle, or it is not such that the springing line and the center will come closer. It will only be a part of a larger arc. The semicircular arch is actually a modification of a segmental arch in which the center lies on the springing line and the shape is that of a semicircle. So that means the center will lie on the springing line here. So in this case, the rise of the arch is going to be half of the span, because that's the radius. It's a semicircular arch, so half of the span will be equal to the rise. The horseback shoe arch, in this case, the arch is shaped like a horseshoe, incorporating more than a semicircle. So it's slightly more than a semicircle. The pointed arch, also known as the Gothic arch, consists of two arcs or circles meeting at the apex. So we have two arcs which are meeting at the apex. The triangles formed may be equilateral or it may be isosceles. So this particular triangle which is created might be isosceles as well. The Venetian arch is another form of pointed arch which has a greater depth at the crown than at the springings. So we are making it a bit less here and we are giving a greater depth at the crown. This type of Venetian arch has 4 centers. Now all of these centers are located on the springing line. So very different from a segmental arch in which the center was far below the springing line. Here all the centers, all 4 of them, will lie on the springing line. The Florentine arch is similar to the Venetian arch except that the intradose is a semicircle. Intradose is reminding you the inner arc of the arch, and this will form a semicircle in the Florentine arch, making the arch have 3 centers also located on the springing line right here. 3 centers. The relieving arch is constructed either on a flat arch, so you can create a flat arch, which was the first example we had seen, or we can use a wooden lintel to provide greater strength. So some sort of a support is there on which the relieving arch is created. The stilted arch consists of a semicircular arch with 2 vertical portions at the springings. The semi-elliptical arch is a type of arch has the shape of a semi-ellipse and it may have 3 centers or 5 centers. Here is an example of having 1, 2, 3, 4, 5 centers. One-centered arches are segmental arches, semicircular arches, flat arches, horseshoe arches and stilted arches. So under the category of one-centered arches, we can have 1, 2, 3, 4, 5 types of arches. Sometimes we can also go for a perfectly circular arch, which is also called the bullseye, as we can see in this figure. It's a complete circle, very commonly used even in old constructions where we have stained glass windows, and we can go for a bullseye arch, very applicable for circular window options. The two-centered arches are pointed arches, which are under this category. So we will have to look for pointed arches like the semi-elliptical Florentine arches, which are pointed in nature. They will have 2 centers or more. Three-centered arches are elliptical arches. Under this category, we know that they can have semi-elliptical arches can have 3 to 5 centers. 4 centers have 4 center arches. In this, Venetian arch and Tudor arch are included. We can also go up to 5 arches, which we've 5 centers in our arches, as we've seen in the semi elliptical option. So those were the classification based on the number of centers and definitely the number of the type of shape that we have given to our arch. Now let's take a look at classification of arches based on material and workmanship. So stone arches can be rubble arch. These are comparatively weaker, used for inferior work, and are made up of rubble stones which are hammer dressed roughly into shape and the size of voisers, and they are fixed together with cement mortar. But if we want to go for a much more regular shape, we can cut the voisers into regular ashlar shapes, and they are fully dressed and set in cement or lime mortar with proper bed joints. So these will be proper bed joints, regularly shaped to create ashlar arch. So that's types of stone arches. Moving on to brick arches. Rough brick arches are constructed with ordinary bricks without cutting them to the shape of voisers, and they are not used for exposed brickwork. But if we go for axed brick arches, here the bricks are wedge shaped and they are cut with the help of a brick axe, and it does not have a pleasant appearance because the bricks are not very finely dressed. In case of the gauged brick arch, here we are preparing the bricks to the exact size, which we can see here. Okay, here it is regularly shaped. The size and shape of the voisers are very fixed. We use wire saws for this, and the surface of the bricks are very finely dressed. In case of the last type, which is the purpose-made brick arch, here the bricks are manufactured for this type of arch. So we will create bricks which are the exact shape, size of the voisers, and very fine workmanship will be used for the purposes of this type of brick arch. So we can have 4 types of brick arches based on the finishing or the level of workmanship that we have applied. The first is rough brick arches, followed by axed brick arches. Here we are cutting the bricks with brick axe. The gauged brick arches, which we are using wire saw to cut the bricks. A little bit more pleasing appearance than the previous 2 examples, but not as much as purpose-made bricks, where exact sizes of bricks are created and fine workmanship is used to fix them together in this particular type of format. So we have stone arches, brick arches. Now let's look at concrete arches. Now here precast concrete block arches can be used. These arches are made up, as the name suggests, from precast concrete blocks, and each block is cast in a mold to the exact shape and size of the voisers needed. It gives a very good appearance because we have a very regular shape to the arch, and each of the voisers looks identical, and they're fixed with cement concrete. We can also go for monolithic concrete arches, which are casted on site. So we are creating them in situ, either plain or reinforced. So we can either have it with just cement concrete. We can also introduce reinforcement bars to give additional strength to this. And depending upon the span that we are having, that is how much is this particular span, or the magnitude of superimposed loads that are coming onto this arch, how large the span is. Based on this, we can design how much reinforcement we want within our monolithic concrete arches. So for this, of course, formwork, we will learn about formwork towards the end of our course, but formwork, shuttering has to be done. We have to place some support system for us to be able to make this arch, cast it in situ, and once the construction is done, these temporary structures are removed when the arch has already taken shape. So for that, we can use timber parts. We can even create some support mechanism using bricks, which are later dismantled after the arch has come together. Construction of arches are carried out in various steps. I had just briefly started discussing about them, so let's take a look at in detail. The first step of creating an arch is that we have to do centering. So how do we install centering? Centering is actually a temporary structure which is required to support brick, stone or concrete arch during its construction. Till it gains sufficient strength to independently stand on its own. So up until that time, we'll have to give it some amount of support. So for that, we do the installation of centering. Usually it is made up of timber or steel. wooden centering is the simplest and the cheapest option which is available, especially if we are dealing with a moderate span. For larger spans, we can also go for other stronger structures. We can even use bricks to create such structures. Here, if we see in elevation, there is a turning piece which is creating the intrados on which the arch will be sprung. We can create wedges and hold them on top of props. So it's very similar to what we are trying to do the arch itself. That is, we have the abutments, we have the springing point, and then we have the intrados on top of which we are having the arch. So we would require timber posts or props, wedges, and the turning piece. This will remain in position up until the arch in question has gained sufficient strength, after which it will be removed. Then comes the next step, which is the laying of an arch. After the installation of centering, skew backs are prepared. Those were the points at the edge of the arch. These are the skew backs. After the installation of centering and skew back preparation, the voicers are arranged in proper and required form. We will start from the skew back, that is from this point, and we will gradually move towards the crown. The crown is the highest point of the extrados. So we will move in this direction. Finally, we will place the keystone, that is the final key, which is at the center here. This will be inserted and all the voicers will be locked in their respective positions. The last step is the removal of the centering. So when the arch has developed sufficient strength, the centering can be removed. No load should be pre-placed on the arch unless the centering has been removed. So any form of superimposed loads we do not want to place directly on the arch. Any form of construction above the arch should be done after the centering has been removed, and that means that the arch has been finally prepped and has gained its sufficient strength. If you are using timber centering for wider soffits for bigger spans, in that case, in addition to the